Hi, Robert. How are you today?
Hey Ferris, I'm doing great. How are you today?
I'm well, thank you. Robert, can you please introduce yourself and tell us a little bit about what you do?
Well, good afternoon, everyone. My name is Robert Clark. I'm a facility mechanical engineer. I work for I work for a support service contractor by the name of HX5 Sierra. We provide testing facilities, engineering operations, and maintenance services to the federal government. Specifically for us, we currently support the NASA Glenn Research Center located in Cleveland, Ohio, and its companion test facility, the Armstrong test facility located in Sandusky, Ohio. The mechanism and test article can weigh up to as much as 30,000 pounds. And so if you imagine 30,000 pounds. If you divide that by four, that's 7,500 pounds on each of those four casters. I don't recall exactly what the maximum point load was, but we exceeded it. But we had to come up with a solution to reduce those point loads by at least, I believe, 66%. So we had to get down to about 2,500 pounds per caster or per whatever the solution was going to be, however many points we were going to have on whatever the solution was going to end up being.
So, how are you getting it into place when you're using the tug? I know that those aren't exactly the most controllable devices, if I
Um,
may say.
for lack of better terms, it's almost brute force because the motorized tug is a push button mechanism. So you'd push it in the direction you'd want to go, and and it would go in that direction. But there were times when you know and this is not every time that we used it, but there are times when we would line up the motorized tug, and we'd get the test article in place, and it would just be like a half an inch out of location before we could get it installed. Well, you think, it's a half an inch, you could just use brute force. Well, you're not moving 30,000 pounds with brute force. You're still using that motorized tug, and you're moving it, and you say you're pressing the button for it to go forward. Well, just because it goes forward, it doesn't know that you only may need a half an inch. It just goes, as far as you tap it with your finger, and maybe you push it the first time, it goes forward an inch. And we're like, well, now it's too far. Now it's too far the other way, a half an inch too far the other way. Um, so then you go backwards, and then hey, maybe it comes back. Hey, maybe it only goes back 5/8, and now you're only an eighth of an inch away, and it's that play back and forth that we had to deal with, uh, that at times was frustrating, but we worked it the best we could to get the test articles installed in place.
So, positioning like that, would that require additional people? Would it cause a risk of injury, or was it just trial
Um,
and error?
certainly, it was all of the above actually. We would certainly need more people because you'd have the person that would be driving the tug, and you'd have that person sort of taking care of that operation, and then you'd have people that were, I don't want to say suspended from the test article because they weren't, but they were climbing up on the test article close to where that hangar that I previously mentioned, to where it had to connect to the hangar. So those folks are like, they're super close, and they're literally right on top of it. So
Wow.
yes, it could be a safety issue, um, but again, we would only do what we would have to do to get it, or we'd only do what was safe to get it in place, and not put anyone in jeopardy. Now, with the HaloDrive system, none of that has changed. We still have folks that need to climb up because we still have to align it with the hangar, and you still have to know where it goes. But with the HaloDrive system, it's not just brute force pushing the button and hoping that you get it there, because with the HaloDrive system, you know, and again, you can't dial in a specific value for it to go, but there's just so much more. Um, what's the word I'm looking for? Is uh,
Control, accuracy.
Yeah, yes. Thank you, Ferris. Accuracy is actually the best word that I could think, or that comes to mind, that you just said. Um, you know, with the remote control and Halo Drive system, we can tap it, and it would literally move just to tap, and sometimes That's all we need. And then there's some cases where with the old motorized tug, it can only go forward and backward. Great, goes forward and backward. We'd have to use a little manual labor if we needed to go from side to side.
Sort of
And
like parallel parking a car?
yes, yeah, it can be that much more difficult. But with the HaloDrive system, not only can we go forward and backward, but we can also go side to side. So there's literally the brute force, as I like to call it, the brute manual labor that we had required in times past is no longer necessary. Basically, you still have folks that, as I said earlier, need to climb up and help guide the test article in position and to get it in the position where it can be attached to the hanger. But now you don't need people to climb down and forcibly try to move the mechanism to go. Not only we need to go 3/8 of an inch forward. Now we need to go like a 16th of an inch. I mean, 16 inch to the right or to the left, and the HaloDrive system allows us to do all those things, and it saves us time and also puts people in a safer position because they're doing less manual labor.